Okay, so here's another approach that may make a little bit more sense on doing the horizontal reflections, on doing those kind of ones here. So what I did was I went ahead and drew two little graphs, one for problem number 8, one problem number 9. I know you have them for homework tonight, and I thought maybe it'd be easier to kind of help you through those problems. So pay attention to what I'm doing. Just don't randomly just type in the answer and then just, but think about what I'm doing here. So first, I think what I was thinking on the way home from school was, let's go with just graphing. Let's just graph what we see there. And again, use the graphing calculator to do it. And when you do the graphing calculator, what you're going to notice is this number 8. This one will have the vertex will be at 1,3. Bear with my husky. He is deciding to be a little bit nosy and bossy since I've gotten home. And so there's where my vertex is at positive 1,3. And it's got a slope of 2 on the x, so that means I get to go up 2 over 1, put a dot, and then go up 2 and to the left 1, put a dot. And there is my graph. And that's what you should see on the graphing calculator. And so now we have to think about, they want us to reflect over the y-axis. So that means I got to take this vertex and move it over the y-axis, which means instead of it being at 1, 3, it's going to be at negative 1, 3 is where that's going to be. It's going to be at negative 1, 3. So now what I can do is I said, you know what, the y part, the up and down didn't change. I just got to change it to be absolute value of 2x plus 1 and then plus 3 at the end. Is what I need to go through and do. Because the V, again, it's like what I did in the classroom when I just flipped around 180 degrees and faced the board. You stayed put on, you just moved over from one side to the other. You pivoted over the x-axis, or over the y-axis. Again, I apologize for my noisy husky. On number 9, we're going to do it the same way. Let's go ahead and graph it. So when you go to graph it on the calculator, it's going to be graphed at positive 11, negative 3 for a vertex. So I go over positive 11, down 3. There's where the point is. It's got a slope of 1, so it's going to be a nice normal V because there's a 1 in front of that X. And then now they're saying, all right, again, I want to reflect this one about the y-axis, so I have to take this and go all the way across, which means I was at positive 11 here for where the point was horizontally. So now it's going to come all the way over here to where now it's going to be at negative 11, 3 is where that V is going to be. And then we have our little V at that section there. So with that in mind, our equation is just going to change to be negative 3 plus absolute value of x plus 11 is what's going to happen here. We're changing the sign mainly on just the inside part because we're reflecting over that y-axis. And then I'll go ahead and do the next one for you while I'm at you just to get a horizontal shrink, because I always think the horizontal shrinks and reflections and compressions are always, and stretches are always the hardest ones. The vertical ones are pretty easy because it stays on the outside and you got to distribute to both parts on the outside. So on this one, it tells me I'm doing a horizontal shrink of a factor of 2. So that means that I actually have to multiply the inside. Because again, when we're doing a shrink, we have to do the opposite of, instead of dividing by 2, we got to multiply by 2 on the inside. So that's really like saying the absolute value of 2 times 2x. And then plus 4, and we should get the absolute value of 4x, and then plus 4 is what we should be doing next. Again, sorry for my noisy husky. Text me if you got any questions.